Reit, hwnna, dipyn yn catraffaeth efo'r cwestiwn particles yn y mock. So the particles question, which is usually the last question on the paper. Dach chi eisiau cofio eich quarks ydy up, down. Ydy gennych chi, obviously, anti-up, anti-down. So charge, Q, ydy hwnna, ar yr up ydy plus 2, mae hyn I gyd yn y data book, okay? All these are in the data book, so the anti-up is just opposite, opposite the up, the anti-down is opposite the down. So those are your quarks. We also have leptons, the only two leptons, first generation again, are the electron. Charge is -1. A mae gennych chi'r neutrino, neu'r electron neutrino, charge 0. Yr anti-electron, da ni'n alw'n positron, so mae gen o symbol I hun. Okay, it's got this, its own symbol, this plus sign there, positron. So it's got charge +1. And the anti-electron neutrino, again, opposite of 0 is still 0. Dyna fo. Wan, beth sydd gennym ni hefyd efo lepton, ydy lepton number. Okay, we've got the lepton number, which is, if it is a lepton, it is +1. If it's an anti-lepton, it's -1. And then over here, it's going to be 0 for all of these because they are not leptons. A dyna cwbl dach chi eisiau wybod, na I fynd drwy'r cwestiwn yn y bit nesa. Okay, so question 7a, so an electron and positron can annihilate, destroy each other in this interaction. So we have an electron, a positron, and beth I hein ydy 2 gamma ray, ond 2 photon. Explain how lepton number is conserved in this interaction. Cofiwch lepton number, os di o yn lepton, mae'n +1. Okay, so a lepton is +1, so the E has lepton number +1. The positron is an anti-lepton, so it has -1. And right, photon plus photon. Well, the photon is not a lepton, so 0, 0, +1, -1, and 0 is 0. So take him. Pa rym sydd yn charge of yna? Well, if it was the weak force, then there would be a neutrino. Dos o ddim neutrino, di o ddim yn weak. If it was the strong force, they would all be quarks. Well, there's not a single quark there. It's not the strong. Mae rhaid felly bod o yn electromagnetic. A cliw arall ydy photon. Os oes y photon yna, fydd y photon, it is electromagnetic. Right, rhan B. Pa the proton and an antiproton can annihilate each other in this strong interaction. Okay, dyn ni'n gwybod yn strong. By applying conservation rules, suggest the identity of particle X. Well, mae strong yn deitha ni, we're all dealing with quarks. It must be quarks, so this X must be made of quarks. So dim leptons o gwbl. One, conservation rules. So let's start with charge. Charge of a proton is +1. Charge of an antiproton, -1. And right, pi plus +1. Felly dyn ni chwilio am charge o -1 ar gyfer y character bach yma. Conservation law arall, well, so ni gallu apply o lepton, ond da ni wedi gweithio allan yn barod. Okay, we've already worked out its quark, so we know that the leptons are going to be 0, 0, 0, 0. So it's not a lepton. Na I reid o lawr, just rhag lepton number is 0 and 0, giving you 0 and 0. So it is not a lepton. Be sgynnon ni sydd yn gwefr -1 ag ddim yn lepton? Wel, sort o cliw yn hwn. Pi plus, which is an down, anti-down. Sorry, nage, up, anti-up. up, anti-down. Sorry, pi plus is up, anti-down, yeah. Plus 2/3, plus 1/3 i reid charge o plus 1. O, yr un amlwg felly i ni yn fama di y pi minus, which is down, anti-up, minus 1/3, minus 2/3. Dydy hwnna ddim yn un hawdd, okay? It's not an easy one to work out. Right, part C. Da ni'n gwybod bod yr pi plus yn ansefydlog. The pi plus, this pion, the meson, is unstable. It can decay thus. So pi plus goes into Y plus an electron neutrino here. So identify Y. Again, conservation laws. We know charge is conserved. So we start with plus 1. Gives us something. Mae'r neutrino has 0 charge, so we must be looking for something with a positive charge, plus 1. Lepton number. We've got the pion, which is 0, becoming something here. And the neutrino is a lepton, so it's plus 1. So to go from 0 to 0 on this side, this must have a lepton number of minus 1. Right, what do we have that is a minus 1 lepton number? So minus 1 means it's an anti-lepton with a charge of plus 1. The only candidate is the positron. That's your answer. Which force is involved? We've got this here, the neutrino, so it must be a weak force. Show below an equation how the pi minus might decay. So we start with a pi minus. By the way, mae hwn yn clw, yeah? They've told you the answer to a previous question there. Heb drio, dwi'n meddwl. The pi minus becomes well, we got minus 1 on this side, and well, I copio'r model yma, we could have neutrino here. Problem that sgynna ni di, da ni eisiau charge minus 1, sgynna ni ddim anti-lepton. Obviously, the lepton numbers are going to be 0. That's plus 1 at the moment. We need this to be minus 1. We don't have an anti-lepton with a charge of minus 1. So we'll have to adapt all this. We have an anti-neutrino here. And then we can use lepton number plus 1, charge of minus 1, our friend the electron. A dyna chi, 8 allan o 8.